Good afternoon. For the extemporaneous of the second unit, I chose the problem 3.29 that says that the indicate location of center of gravity of the 3,600 pounds pickup truck is for the unladen condition, and if allowed, whose center of gravity is x equal to 16 inches behind the rear axle is added to the truck, determine the load weight WL for which the normal forces under the front and rear wheels are equal. Okay. And we have two unknowns in this problem. And the first thing that we need to say is that and the problem says that and we need to find the load weight for which the normal forces are equal. So we can write the the normal forces as an equality. So NA is equal to MB. So, and another unknown is and the weight of the load. Okay, these are the two unknowns. So for that, and in the first, which is the thing that we need to do is make the diagram of forces. And I found this image of a truck in internet, so I choose it to make the diagram of forces because it's very similar to this truck. So I wrote the center of gravity of the truck as W, the center of gravity of the load as the weight of the load, and the wheel A and the wheel B, and the forces. And in these wheels, I name it NA and NB because are the normal forces in A and B, and these are the distances between the normal the wheel A to the center of gravity, the wheel B to the center of gravity, and the X, which is the distance between B and the weight of the load, which is 16 inches. Okay, um, I already make like uh, the equations of this to make the video shorter, so I'm going to explain these equations. Okay, the first thing that we need to do is and take like the sum of all the momentums in A as 0. That's to calculate the normal forces in B. So for that, we can make an equation for the normal forces in B. Okay, the first thing that I wrote is the the center of gravity times the distance between and the wheel A and the W. So it's W times the distance. Then I wrote minus the normal forces in B times the distance between the normal forces in A and the normal forces in B, which is 45 inches plus the 67 inches we have here, plus the weight of the load times the distance between the normal forces in A and the weight of the load, which are and the three distances, which are the 45, the 67, and 16 inches. All of that is equal to zero. So we can write the equation in terms of MB, and we pass this MB to the left, and we can make this equation, which is MB times 112, which is the sum of the distances from the MB and the NA, which is 45 plus 67, which we can watch that is 45 plus 67, which is 112, and plus the weight, which is the 3,600 pounds, times the distance between the center of gravity, which is the weight, and the wheel A, which is 45. So then we pass this distance, which is 112, and here is multiplying empty, and when we pass to the right side, it's dividing the whole equation of here. So we have that WAL times 128 plus this is the product of multiply 3600 for 45. Can make it here 3600 times 45, and we have the 162,000. Okay, now making this, we need to make the division between this and this and this and this, and we're going to separate in two ways, like to make an equation. So from this, we're going to do 128 over 112, 128 over 112, and we have 1.142.8. So we can round it to 143, and we have another which is and 162,000 over 112. So 162,000 over 112, which is 1,446.428, and we can round it to 43. Okay, now we have the equation in terms of MB. For the next one, we can say that the sum of the momentums on B are equal to 0 to make an equation in terms of the normal forces in A. So we start to and write the terms of the first weight, which is minus W, which is the 3,600 pounds, times 67, which is the distance between the weight and the normal forces in B, plus the normal forces in A, times the sum of the distance between the wheel A and the wheel B, and it's the same addition as this, so it's going to be 112 again, plus the weight of the load times the distance between the wheel B and the weight load, which is 16 inches, and this is equal to 0. So we can write the equation in terms of NA. So we can pass the weight this part, the W times 67 and the WL times 16 to the right. So for that we have NA times 112. It's equal to minus weight load times 16 plus the weight, which is 3,600 times 67. Okay, for that we have the same as here. We pass the 112 to the right, and he's multiplying, so here is dividing. So we have minus WL times 16 plus 2,400, 241,200, which is the multiplication of 3,600 times 67. So we're going to do it. It's 3,600 times 67, and it's 241,200. So we make the same as here. First, we're going to divide 16 over 112, which is it's minus 16 over 112, and it's minus 0.143. Okay, it's 16 over 112 needs 0.142.8, so we can round it to 143. And from here, we're going to divide 241,200 over 112, and we had 112, and it's 2,153.57, and is what we have here. And we have the equation of normal forces in B and normal forces in A. So from there, we can calculate the weight load because we have the first unknown, which is this one. So I'm going to move here. This. Okay, we're going to move this from here to here, and we have the next. So to calculate here, we have that NA, well, we have that NA is equal to NB. So because of this, we have the next question. It is the same as this, so we can copy this. So we have this equality, or say that NB is equal to NA. This is going to put this again. So this is equal to this. And there we have. This is equal to this. So from there, we change the variables. And we can write it in this way. We can write it as 1.143 WL plus 0.143 is equal to 2,153.57 plus 1,446.43. I'm sorry, here is minus. Okay, from there we make the sum and the rest from here. I'm going to zoom it. Let's move this from here to see it. We have 1.143 plus 0.143, and it's 1.286. So we're going to write 1.286 WL, here to WL, is equal to 2153.57 minus 1446.43. And it is 707.14 was 707.14. From there, we can change this to another side, and we have that WL is equal to 707.14 over 1.286. And after that division, we have that the weight of the load, it's equal to, we're going to make this division, it's 707.14 over 1.286. And we have that the weight load in order to the normal forces in the wheel A and the wheel B are equal, it's 549.87, and we can round this as 549.88, so we can write it as 549.88 pounds. So this is the answer for this question. And I repeat, the problem asks to find which is the weight of the load in order to for which normal forces are under the front and rear wheels are equal. So this is the answer for the question.